Hello everyone, my name is Karthik Adi. Today I am going to present my IoT internship titled Smart Factory Monitoring System mentored by Amarji. In this internship, I have gained strong understanding on how IoT systems are designed, starting from sensors, data collection, and all along with the visualization cloud and control. And along with, I have gained strong hands-on experience on MQTT communication, which is real-time IoT application used for efficient data transfer. What are the technical concepts I have learned in this internship? I have learned programming using C++ in Arduino IDE, sensors interfacing like DST22, LM35, LDR, PIR, and wireless communications like Wi-Fi or MQTT, and data visualization, starting from sensors to network, then cloud, lastly dashboards, and real-time monitoring system and automation. What are the tools and platforms used? In this Arduino IDE, Exim Lab, ThinkSpot Cloud. These are the three tools are used. Introduction to IoT. IoT means I, Internet of Things concepts connects physical device to internet for data exchange. In IoT, devices collect data using sensors and send to cloud platforms, which enables remote monitoring, control, and automation, widely used in smart homes, industries, and healthcare. Problem statement. In traditional factories lack real-time monitoring and automation, and manual supervision leads to inefficiency and delays. Equipment failures are difficult to detect early, and no centralized systems for data monitoring and analysis. Solution. In solution, two node IoT architecture with production and warehouse. Firstly, production node. Produc- Production nodes installed on production line to monitor machine conditions, uses sensors like vibration and temperature to detect faults and performance issues. Warehouse node monitors storage conditions in warehouse environment, uses sensors like LDR, PIR, and temperature sensors. Lastly, smart factory node acts as the main control and monitoring unit, receives data from the both production and warehouse nodes via IoT. System overview. Sensors collect like environmental and machine data. Microcontroller processes and sends data, which Wi-Fi module transmits data to cloud. Lastly, dashboard displays real-time information. Communication to IoT. In this, data is transmitted using MQTT protocol over Wi-Fi. My, Microcontroller publishes sensors data to broker. Next, cloud platform subscribes and displays the data. Lastly, it enables real-time monitoring and remote access. PubSub client library. PubSub client library in an Arduino library used for MQTT communication, which enables publishing and subscribing to data topics. Lightweight and suitable for embedded IoT systems. Works with ESP8266 or ESP32 for cloud connectivity. Sensors. What are the sensors used? Firstly, I will say about DST22 sensor, which measures temperature and humidity, and it has high accuracy and digital output. LM35 sensors. It is the analog temperature sensors. It gives output voltage proportional to temperature. PIR sensors. It detects human motion and used for security and automation. Vibration sensor. It detects machine vibrations and useful for fault detection. Production line. In production line, it monitors machine status and working conditions. It detects faults using vibration and temperature sensors, and it improves production efficiency. Warehouse. It tracks environmental conditions like temperature or light and detects movement using PIR sensor, ensures safety and proper storage conditions. Things board dashboards. It visualizes sensors data in real time, displays graphs, alerts, and system status. It helps in decision making and monitoring, and it is accessible remotely via web interface. Now I will show the project demo. This is the node node 1 file. In this I have included libraries like spi.h file, ethernet.h file, WhatsApp client.file, dst.h file. These files are used to send and receive the data. Next, config.h file. In this file, we have client ID, access token, server ID. Next, sensor manager.cpp file, sensor manager.h file. These files are used to sense the devices like LM35, LDR. Next, actuator.h file. These files are used to control the output of the device. Next, network.cpp and network.h file. These files are uh, used to communicate, used for the communication. Next, telemetry.cpp, telemetry.h file. These two files are used to send the data to the cloud. Last, rpc.cpp, rpc.h files. These files are used to for the relay status like turning on and off LED. Next, I will open the Pixel lab. First, I will run the code. Sketch, export compiled binary. This says code is compiled successfully. Next, I will go to the Pixel lab. Here, I will upload the code loadex file, loadex, download one file, build. Here you can see LEDs are blinking. First, I will tell the V terminal. This is the V terminal, and this is the W55 and W5500. This is the LM35. This is the DST22. In this temperature, we have temperature and humidity, and this is the vibration sensor. This is the machine control. These are the LEDs, and this is the relay status. You can see green light is blinking, saying that still Thingsport is not connected. Now I will upload the file again. Loadex, node one file, upload. Here, three LEDs are there: green LED, yellow LED, red LED. Now I will link the yellow LED by by disconnecting sensor value. I will upload to 0. Error is there. Now I will go to the things board. This is the main things board file. Here I have created temperature, humidity, and these are the LEDs. This is the time series start, and this is the time series table. These are the alarms. I will explain further. Now I will use fixing that. Now I will change the temperature and humidity. When I will when I change the temperature and humidity, these these temperature and humidity are changing. Next, these I will show these LEDs. As you can see, machine status is on. When I will tap for the few seconds, the machine status LED will on and off for 10 seconds. When I will hold the machine control button, it will be off, and further it will be on. Next, I will show the sensor error. When I will disconnect the sensor error to 0, okay, the sensor LED will be on, showing that error is there. Then I will reconnect to the code 2. Okay, now it's showing sensor error is not there, and this is the LA status. This can be shown by switch control button. When I will on the switch control button, showing that less status is less status LED is on. When I will off, here less status LED is off. And this is the time series chart. In this we have temperature and vibration for showing the graphical method. These are the temperatures time series table. Here we have temperature, humidity, LM35 temperature, machine status, LA status, sensor error, vibration. These are the alarms. When I will change the DST, DS22, DST22, in this I will change the temperature and humidity, and I will change LM35, showing that temperature is critical and vibration is critical. This completes the production line 1. Now I will show the demo 2. It is node to file. It is same as the node on file. All files are remain same. Now I will verifies the sketch. It says sketch is compiled successfully. Now I will open Exim Lab. Here I will upload the code. Node to code one. Here these three LEDs are there. First green, yellow, red. These are the V terminal. This is the door switch, and this is the LDR. This is the DST22. In this we have temperature and humidity. This is the W5500. This is the machine sensor by controlling the switch, and these three are the LEDs, and this is the ventilation relay. Now I will change the values in PixSimlab and apply changes in things code. And this is the warehouse things board. Now I will change the values and apply changes in warehouse test. Now I will change code and observe the changes in warehouse test. Here I will change the temperature, humidity. You can see the temperature and humidity is changing. Next, I will change the LDR value. When I slide up the LDR, the value is increasing. Sorry, value is decreasing. When I slide down, the value is increasing. Next, I will show these LEDs. First, I will show the door status. When I will on the switch button, the door status LED is on. When I will off, the door status LED is off. Next, I will show the motion detector. When I will hold the motion sensor button, the motion sensor LED is on, saying that motion is detected. After some time, it will be off. Next, I will show the sensor error by disconnecting the value to 0. Okay, as you can see, yellow LED is blinking and sensor error is detected. Now I will reconnect to 2. Okay, as you can see, sensor LED is off. This is the time series start. This is the time series table. In this, we have temperature, humidity, IDR value, motion detected. These are the alarms. When I will change the DST22. In this, we have temperature and humidity. And I will change the temperature. This alarm showing warehouse is dark and humidity is critical. Warehouse dark is showing warning. High humidity is showing critical. Next, additional to this, we have smart factory. Let's open that. This is a combination of those two dashboards. In this, we have warehouse test and production test. In warehouse humidity, door opening temperature, motion detected, is dark, and IDR value. Production light test, humidity, LM35 temperature, machine status, sensor error, vibration, temperature, and this is the time series start. In this, we have temperature and LM35 temperature showing in a graphical method. This completes my project. Thank you for listening till the end. Once again, I will sincerely express my gratitude to Emergy for giving this opportunity. In this internship journey, I have learned how IoT systems are designed, and I learned how ThinkSports are connected using Think Lab and sensors, and it has improved my programming skills and debugging skills.